to the power x. See, same questions, same structure. See, no, tan. That is what this topic is about. See, log. Yeah, fx is equal to this. Now you might think, oh man, this is hard, so I will switch this to geography. Do you want me to show the geography paper? It's the same. You might, so some people think like that. Oh man, accounting is hard. I will do business studies. Biology is hard. I will do psychology. They don't know psychology is harder than biology. They don't know that. So, but anyhow, okay, guys, this is the paper we have to set. Okay, so we'll try hard. Now, knowing that, we'll start trigonometry. I'll show you this message I got, right? I'll show you the real nozzles. She got the nozzle price last year. Last year? Methods price, yeah.
No, we get different prizes.
I think high achievers or something. What do you call it?
Huh?
High achievers, right?
I don't know.
Who was it?
Anuji. I'm showing you this email so that this will give you some encouragement. This email just came, okay? 6:25 just came. Hi sir, do you mind sending me an extra exam to me and Shannon so that or whatever classroom, so that we can print and do tomorrow morning? I'm not asking them to send, they are asking me to send. Now you understand your location is. Okay? They are asking me to send. I'm not assigning anything. Right? Send me the paper so that they can get the printout and do the paper. They are coming to tomorrow's class 5:30 a.m. in the Dandino. If you want to check, you can come 5:30, they're there. With this, she scored, I think 97 or 98 for the math SAC last time. For the physics also, she got the highest, 95. Yeah. And that girl in Nozzle. Okay, so your colleagues. So check, if you want, check who is you. But that's what it is. Okay. Okay, guys. So, little bit of stuff. So, trigonometry. Now, trigonometry, but if you check the book name is circular functions. Circular functions. Now, Terry, you know this, right? Yeah. So I think Terry knows everything, right? So that means I'm going to drill you.
Right.
Okay. So trigonometry, I will tell you why this is called circular functions later. There is a reason behind it. Now trigonometry means tri-geometry. Tri means three, geometry is geometry. So three sides, that's trigonometry. Now in this trigonometry business, we have two things. One is with right angle triangles. Second one is non-right angle triangles. Okay. So if you have a right angle triangle, okay, if you have a right angle triangle like this angle, this is theta. You are familiar with those, right? Theta. This is A, B, C. You know that that you remembered. I know Sakatova or something. What is that? Sokotova. Oh, what? Okay. So Sokotova. Okay. Whatever. Okay. Because when I was a kid, I didn't use that, so that's why I don't know. Cos theta, tan theta. Huh? Yeah. So sine theta, cos theta, tan theta. We will discuss what is sine, what is this thing, right? So this concept sine, cos, tan. They are coming under right angle triangle. Under right angle triangle. Now, if it is a non-right angle triangle, this is year 9 knowledge, okay? Sometimes when you are in selective school, you might have learned this. Suppose this is ABC, and this length is A, the opposite length is B, opposite length to this angle is C. This is a non-right angle triangle, right? Now, in this business, what do you have? Now, can you see, like, I am giving my knowledge onto the board? So, likewise, what is your knowledge about that? There, you have two rules, only two rules. We call it sine rule.
And cosine rule.
Yes. Sine rule and cosine rule.
Sine is an angle.
Okay.
So
Sine rule and cosine rule.
the degree of
Yeah.
A over the degree.
Now, first of all, we will understand what is sine rule and cosine rule. We will finish this part and we will move into here. So this is the biggest part. This is the biggest part. And this is co-area. We are touching the co-area now. Please understand because you can see. Oh, good. Now sine rule. Okay, so A here, B here, C here, A, B, C. Sine rule tells you that sine of A angle divided by the corresponding length. So this angle is A, okay? This angle is B, this angle is C, is equal to sine B divided by B is equal to sine C divided by C, capital C, okay? Okay. Ina, can you check whether it's recording? Is there?
Yeah.
Yes. Now, or some people write this way: A divided by sine A, B divided by sine B, C divided by sine C. That is the sine rule. Any questions? You know this, right? You know this. Yeah. You know in grade 9, typically we learn this. But I don't know how your grade 9 was because of the COVID. Maybe a piece of crap. No, right?
I'll have to summarize.
Yeah. Sine rule. Now, the sine rule and the cosine rule is not that important in our business. I'm just showing you for the sake of completion. Now, when it comes to cosine rule, okay, Terry boy, tell me cosine A. Cosine cos A is what? Anyone? You know that? I forgot your name.
Yeah.
Yeah, to
No. I forgot it.
Where is it? Cosine rule. What is that?
B squared plus C squared minus A squared.
Okay, you tell me.
Like cos something something.
You tell me.
I don't remember fully, but it's like I remember it was something with like B squared plus C squared minus A squared and then take away cos or something like that. I don't remember exactly the rule.
Okay.
That's
so
how I learned it anyways.
I'm glad at least you remember something. You are right. Minus A squared divided by what is that something?
Is it
You are right.
Okay.
Your numerator is right.
Isn't it?
2b squared. Now, how do you remember this? How, you know, I have a hard time to remember your name,
Me.
right?
That's okay.
So how I am going to remember this,
Okay.
right? I mean, impossible, right? Like when I was a kid, I knew my problem. My problem is I can't remember. I'm telling you the truth. I knew it when I was a kid. Then I used some techniques to sort of remember the things. Okay, I'll tell you that technique. You have A, right? Yeah. When you have A, the first two terms, not A, something else. If you have A, your last term should be A. That is how I remember. So then I know if you have A, it should be A at last. Then you divide by 2BC here, right? So 2BC would be, how do you know BCO, ACO, PB, whatever? It would be the multiplication of these two, first two. You understand the trick? Now if I give you this from now, tomorrow, cos B, guys, now you tell me what it is.
A squared plus C squared minus B
A
squared
squared
over 2.
plus C squared. Last one would be the one here, and then divide by what?
2AC.
That's how you do it. Otherwise, like, you can remember these things, A, B, C, D. Okay? So likewise, you can do the other one. I'm not going to do. Okay? Alright. Then I'm going to do this. You'll understand. You'll understand. You'll understand this part now. Now I will bring you to grade 8, 9. There, you did this sine of x. Sine 30, sine 20, sine 60, likewise, sine of x. What is your understanding if you see this sine of x? We typically call this is sine function, right? Like fx function. Like fx function, sine x is a function. What do you mean by that? That means if you get sine x is equal to 1, can you do x is equal to 1 divided by sine?
No.
Huh? No, you can't do that. Why? Because this is a function, I told you once as well. So this sine x, there is no multiplication here. There is no multiplication. If you have a multiplication, only you can do this business. This is a single unit with here, like here. Sine function is like this. Sine bracket, right? Inside this bracket, you can have anything. We call it input. You can put 10, 20, 30, 40, 50, 60, whatever. That input would be an angle. That input would be an angle. If you get that input with that angle, that is going to be equal to, okay, a value. We call it output, and that is a value. Okay. Anything? Yeah. Now, note. Plot fx is equal to x squared. Plot fx is equal to sin x. Okay, so I will do it. If you want to plot fx is equal to x squared, how you know how this x squared looks like, right? So you just do this. You know how that looks like. Now, if you have sine x function, the sine x function looks like this. It's a wave, and it goes this way as well. Okay. That's why we say sine function, sine curve, C wave, those kind of sine waves we call it, right? So when you, this is a very common word in electronics, engineering, whatever, if you are interested in those things, if you are doing some IT stuff, electronic stuff, and if you are thinking of some engineering stuff, definitely, if you do any science, definitely other than medicine you need this. Even in medicine you need, you can see in medicine, if you get the oscilloscope, right, heartbeat stuff going like this, you see, right? What do you call it? Stethoscope. What is that? So stethoscope is this, right?
Yeah, that's the idea thing.
Yeah, no, he means the thing like that.
Okay. So fx is equal to sin x. That curve looks like this. Now, if you look into that, if you have a function, we have to specify a domain and a range for a function. Makes sense. Now, for this one, the domain would be what? Minus infinity to infinity. Who told me that? Gracie told me that, right? Remember, for this one, minus infinity to infinity is the domain. Why we are not restricting this to 0 infinity? Why? Because we are not in the context of having inverse functions, right? Now, what would be the range here?
0 to infinity.
0 infinity.
Oh no, I said inclusive.
Now, for this one, what it would be?
The domain or range?
Domain.
0 to 2.
It's all real numbers.
Zero to-
All real numbers.
0 to what?
Isn't it?
It's all real numbers. It's negative infinity, positive infinity. So
I
domain.
won't tell you.
No, that's the
Are
right.
you going to disappoint me?
The right.
It's
Your
range.
x would be,
Negative x to x.
your x would be what?
All real numbers.
X means x, right? All real numbers. Because this
I want to do that.
is extending to infinity minus
You have to do
infinity.
the main.
Oh.
This is extending to this is extending to plus infinity. So domain would be this. What about the range?
Negative x.
0 to 2 pi.
That's the period. That's the period of the graph.
So derive all what?
A period is like.
Derive. What did you say?
Where it repeats. I'm sorry.
0 to 2 pi. This one?
Like right then, sorry. Which,
1 and
thank you.
It's recording. Okay. Tell me the right answer.
And I don't know.
negative 1 and 1.
It should be negative 1 and 1. Why? Because this sine function minimum point here is negative 1 maximum point here is 1. So it's going to be negative 1.
Is that for every sine graph? Is it always minus 1 and 1?
It can be translated up and down, left and right. It can be
There are some, we can modify the sign, but if you have just sign, yes. If you have just this sign, yes. But we can modify this so that this can go up, down like that, right? So we'll come back to that later. Okay, so this is sign. So you have to understand this. Okay? All good, guys? Now we are in the game. Any questions from here? So I wanted to show you how the sine function looks like, right? And once you define a function, you have to define the domain as well as the range. So we have that already here. All good. Then next one, fx is equal to cos x. Cos. How this function looks like?
It goes down first,
Say
then
again.
goes up. It goes from 0, yeah, up, down. Yeah.
Like that. How you do? How you do?
I learned it elsewhere. Yeah, Shema.
Can you see the difference? This is 1, this is minus 1, okay? Can you see the difference between that?
Yes.
It's
The
down.
starting point is different.
Here, here, can you see x here? When x is equal to 0, the starting point is 1 here. Here, when x is equal to 0, you are starting from 0. Same wave, but you know, sort of shifted a little bit. Now here, the domain would be again real. Y would be minus 1 to 1. That's cool. Easy. Okay. Next one is the killer.
The tan graph is.
And so annoying.
Tan is like.
It's
What,
like-
it was
it's
like
like a
that.
chain.
It's like a, what do you like?
It's a chain.
Hmm?
It's a chain.
Oh yeah, I see that, yeah.
Okay.
It does look like a chair, yeah.
Chair?
The tan graph, it does look a little bit like a chair, because it's always like
Oh my
that,
God.
like that, like that.
Someone's not.
Okay. Tan graph looks like this. Look at this.
Yeah, it's kind of like that.
Oh, one thing I forgot to tell you. Do you know radians?
Yeah.
That you don't read radians?
Ah, it's chain.
I know something.
Okay, radians is okay. Radians is another measurement to an angle, right? So radians, we call it radians. Right? Degrees.
You need to contribute and do the high five.
So if you have 180 degree, you know, straight line, right? 180 degree. In radians, you do pi, but you have to write rad.
No, that's basic.
Okay,
The pi.
guys. 180 degrees in radians is pi rad. That's the notation. How come? Like, you know, if I ask you to measure your weight, you will say 50 kilograms, your mass, right? But you can still say 90 lbs. What is lb? Pounds, right? 90 pounds. It's like a different unit, right?
Isn't there supposed to be a C symbol like on the pi?
Yeah.
Yeah. Like no,
Okay,
like
you're
equal
right.
radius.
C.
Yeah, like a tiny C.
Wait, what?
What?
Here.
Yeah, like that. That's how I
Where'd you learn that?
I had like a little symbol. 4, right?
For radians? Yeah. So I have seen that too, because they have some notations to say that. Otherwise, okay. Right? Otherwise, pi.
Good job.
Otherwise, pi is what?
3.14.
22 divided by 6, right? Yeah. Now, if you don't put rad here, so then pi is 22 divided by 7, and how come that is equal to 180 degrees? Yeah. You understand? This is totally different to these guys, right? So the same symbol is used. Okay. So yeah. So what he's saying is right. Sometimes they use pi little c like this, right?
Yeah.
Yeah. In some books they put some symbol so that we know it's not this pi, it's related to the angle. Yeah? All good with that? So then 2 pi is what?
360.
360. Now we are so lazy. Even the Vika people are so lazy. They are not going to put rad. They just said 2 pi. I can show you like in the papers. They just said 2 pi. By reading the context, we should know what they are referring. That if they are referring to an angle, the 2 pi would be 360. Right? So that's their language. But somehow, here, starting from 0, this x should be an angle, right? This angle. So what about this position here? 90, right?
Yeah.
This is 90. This position is 180. This position is 270.
And then that was 260.
Yeah, this position is 360, right?
Yeah.
Now, we will write this in radians now. This is pi. This is 2 pi. This is going to be pi divided by 2. This is 3 pi divided by 2. So you can see in radians is going to be easy. Right? But we are not going to write rad here like that. But rad should be there. Purposely we removed it. Knowing rad should be there. Yeah? Okay, so now we know that. Now, how tan looks like?
How you write degree?
It's a chair.
It's a chair.
It's like
Yeah,
we use like that.
Responding colors.
I don't know how to explain it. It's a it. It does look like it's like this.
It's just independent.
Wait, what should be a chair?
It is a chair. It does look like a chair.
It is a chair?
It looks a little bit like a chair because it
You mean chair?
Yeah, like a chair. Like, yeah. Like. No, like it does go like that.
That's an inverse.
It's a
Shut up. Actually said
See,
I told you
thought
bro.
it was
It's a
a
chair.
chair.
it does though. It kind of does.
No, it kind of looks
Gee,
like
what
what
do your
it
chairs look like?
It looks like what
What's
it
your
said.
kind of like a chair.
It
It's
looks
like
like
a
a
lawn
chair.
chair.
When you
Yeah,
draw it, it'll
okay.
look like a
But
chair.
that's not
Like the
really.
first couple of
It's a chair.
Right.
It's a chair.
When you think of a chair,
No,
you do not think
no,
that.
no,
That's not a chair.
I do not.
I have around 20 years of teaching experience. This is the first time I
Have you ever sat in a chair?
Now,
Right, it looks like a lawn chair. That's not even Like there's like
Like
Yeah,
you
yeah.
can't. It's
That's
complicated.
legit.
Infinite.
Okay, look at this.
Still legit.
This is tan x over here. 0. This position is pi divided by 2.
It looks more like a.
This position is pi. This position, you know that. This position minus pi divided by 2. This position is minus pi. Okay. Now, by looking at this, tell me
I said leave. I thought you said a mute.
the domain.
Don't
What's a what?
don't say it.
Is it all?
You asked for a
Really?
roof once.
Can you shut up? Alright.
Shayma, what was the domain? If you tell me the domain for that, I'll give you a high five. I
The
forgot the
domain.
domain for that. I
Huh?
don't know. Is it? It's not all of it, is it?
It's in.
If I had my underbook, yeah.
It's an asymptote.
Oh, I knew that.
Because one goes to 0
Yeah,
and one
yeah.
goes to infinity.
Ah, no, yeah, you're right, you're right. Yeah, but, shut the hell up, bro.
For me, I
Oh,
said,
okay,
what are you saying?
This is going to be all real numbers. And y, again,
Back in, come on, sorry.
okay. Any question?
Did you say like there was like an asymptote somewhere?
I didn't say that yet.
Yeah.
Yeah.
Yes.
But then I was about to, but I didn't say it yet. Look at the domain and the range. To tell me whether that makes sense or not. I'm asking a big question. Look at the range and the domain. I wrote what you said.
Wait, I didn't say.
Wait, how does x go to?
I didn't say. I said X.
You said all real numbers.
No, I said X isn't all real
Not
numbers.
for X.
Shayma.
Wait, what? Oh, wait.
Isn't I know.
Wait, for Y is it?
I think why it is because
Yeah.
it goes down
Yeah.
to negative infinity and goes up to positive infinity. But because there's the asymptote there and it's like not connected, wouldn't be. I don't think.
Same.
Yeah, no, this is not.
So you are saying this is correct.
Yes.
Huh?
Yes. Yeah.
This
that's
is not.
Yes.
That's not.
This is not.
That's not correct.
It's not.
It's not correct there. Everyone's with me.
Because how does that go over?
Exactly. It doesn't go all the way because it's.
Why not? Like it's repeating like
Oh
that.
yeah. It repeats.
Going like that.
Yeah, but it's a connect.
Like here, this one also going to this side, going to this side.
Oh,
No.
no.
Right.
Like it's just a graph we did before. It's half of it.
Please ask if you have any questions.
I don't know what my question is. I don't know what
Should
happened.
I get it?
Do you know who you are?
What?
What's going on?
I don't know. What's the problem? Do you get it?
Figure it out.
Exactly.
Yeah.
You going?
Okay, tan function
Yeah.
looks like this.
Okay.
Okay?
Yeah.
If you ask me to change it, I can't change it because this is how it looks like.
Yeah.
Right? If you ask me to make me dark, I can't because I am this white.
Wait, you look
Why? This is how I'm thinking. Okay? So this tan graph looks like this. Okay? Then you have 0 here at pi divided by 2. Yes, now you can see as there is a asymptote. And here there is a asymptote. Asymptote, asymptote, asymptote. Everywhere asymptotes, right? Now this curve is repeating. Like it's going like that, right? This way also the same thing. So now you ask me the question.
I'm good.
Timmy.
Now,
X would be real numbers as well because the period. It keeps
Ah.
on going. So
Oh,
all
okay,
X-
okay. No, that's.
All the X.
okay, look at this. This
But
is
then
correct,
why
guys.
would-
Let others to learn. This is correct. Why? Because you can see continuously this is going from minus infinity to positive infinity. Continuously it's going, right? Yeah? But when you look at this x, it is true the pattern is going from minus infinity to infinity. But can you see discontinuities? Right? Like for example, you have a big wall, right? So that wall is coming from minus infinity to plus infinity. That is not a continuous wall. In between you have some holes like that, right? So it is not a continuous though, it is going from minus infinity to infinity. So when you are defining your domain, you have to skip
Oh.
those discontinuous positions.
You have a set notation for that, don't you? It's like
Exactly. I
with
told
the
you that.
Z. Yeah.
Yeah.
Okay. Yeah.
I told you that.
Now.
Okay. So I will connect that knowledge with another thing you know. Here, one other thing you know here. Look at this, guys. Look at this. If you have y is equal to 1 divided by x, that look okay. I would say minus 1. Okay. So it's 1 here. It looked like this, right? Right? Remember? It looked like that. Now you tell me the domain here.
All real x except
All real x except 1. Can you see why you are skipping that? Because this function is not continuous at this position. Yeah, see, it's not continuous. So this position at this point and this point is not connecting at that point. So you have to skip that. Do you remember that I told you that? Yeah. Similarly, y. Y is r skipping 0. Why? Because when you are thinking of y, you can see the discontinuity is happening when y is equal to 0, right? So see, this position, this point and this point is discontinuous. They are not connecting, right? They are merging. So that's why. Now here, we will import that knowledge here. X. Now you tell me where are the discontinuities happening?
at negative pi over 2.
Yeah. So discontinuity is happening here, right? Discontinuity is happening here, right? Then discontinuity again is happening here, right? Yeah. Okay. Now how will you write that? So R, but you have to skip. You have to skip pi divided by 2, yeah? So you have to skip pi divided by 2. You have to skip this one, 3 pi divided by 2. Then you have to skip 5 pi divided by 2. You have to skip 7 pi divided by 2. You have to skip a lot. Right? A lot. Now, and minus side also you have to include right here. Please tell me if you don't understand this bit.
So don't you do it until 360 degrees?
No. Why am I doing that?
Oh, it's fine.
Yeah, just.
True.
It's like
Yeah.
a Z.
Please let me know if you have any question. I will explain. This is core part. Whatever we are discussing here is important for your understanding. Then only you can think. Okay?
So does it skip every two? So 3
We are skipping every position like this. Whenever you have asymptote, see, that's discontinuity, right? This position, this point, and this point is not continuous.
Yes.
Continuous means like
Yes.
skin to skin. They are not connecting, right? All those points we have to skip. So what are the points? Pi divided by 2 is the point. Is this a point? No. But this is a point, right? That point is 3 pi divided by 2.
Are you sure? Are you sure?
It might be methods as well. You can ask.
Why is it exactly 3? I thought it was 2.
Which 3?
The next one after the pi.
Oh, because this is 90, this is 180,
Oh,
this is
yeah,
370,
yeah.
270, right?
Yeah.
270 is written as 3 pi divided by 2. Okay, any questions? Put any questions? All good? Arun? you have to skip all the things. So now technically, if you write it properly, minus 3 pi divided by 2, minus pi divided by 2, and then pi divided by 2, 3 pi divided by 2, it goes on like that, right? And it goes on like this, right? How many points are there to skip now then? Answer these questions, please.
How many points are there to skip? No, because it's infinite.
That means, wouldn't the answer to that be infinite?
Yeah, it should be. You have an infinite amount and not.
But when it be a question like that,
Okay.
it's gonna make you,
Understand?
Probably, yeah.
You understand? Yeah.
it's very somehow like.
Understand why we are skipping. Then what point we are skipping. If you have any question, guess you got it? Yeah. You got it? Now my question, this is how you write. I mean, how many points are there? Infinite number of points are there, right? So this is going this way, that is
The
going
Z,
that way.
exactly. It is the Z.
Huh?
It's the weird looking Z with the other cross across it.
So that is integer Z?
Oh yeah, that's what it is. I don't remember. It's not something to do with that.
You guys are in Nosal, right?
Yeah.
Tell the girl's name right. Otherwise, you get a slap.
Hey, what?
Wow.
Terry knows it better.
Oh,
Huh?
Harry didn't know it. I told him like
So-
10 minutes ago and he didn't figure it out.
Tell me here how to write. Z is integers, right?
Yeah.
Integers. But that is not the right thing. I can see from your faces you didn't understand this. Please tell me. Do you understand what I said here or not? Yeah?
Said mom.
Huh? Yeah, Inaya?
Yeah.
Moment? Yeah? Okay. So you have 0, pi divided by 2 pi, so you understand. So this is the, how come you write this one neatly? How come you write this one neatly? That is what is expected. Okay. I'm going to write it in this way. Understand whether it makes sense. X is a element of R. You are going to skip n plus half pi, where n is an integer. Now,
How do you remember that?
don't write it if you don't understand. If you have this, don't, the math is notations, okay? Math is notations, it's just stupidly easy this. Now, n is integer. Tell me the integer values.
1, 2, 3, 4.
What about 0?
Yeah.
What about 0? What about 0?
Is 0 in the integer? No. 0 is not an
Yeah?
0, it should,
Zero is an integer, why
It's
not?
an integer because if you multiply it by r, it's pi.
0 is not a natural number.
Yeah, because if you multiply it by pi, it's pi over 2. Yeah, it's an integer.
0 is not a natural number. 0 is an integer. So if you put 0 here, can you see pi divided by 2? You are recovering that. If you put 1 here, then you are recovering this. If you put 2 here, next one, 3 here, next one, 4, 5, next 6, you are recovering. If you put -1 here, are you going to recover this? Yeah, you are going. If you put minus 1 here, yeah, you are recovering. If you put minus 2, yeah, you are recovering. So this is how you write the domain for that. Now write it down, whatever you understood. This thing is very important to approach the questions and you know, then we can go from there. Any questions?
No, I got it. Can you explain it again, sir?
Say,
Can you, yeah.
do what?
The domain thing.
Explain again. Do you understand this bit?
Yeah.
Why we are skipping? Yeah. So now, how many terms? How many points? These are points, right? This point, that point, right? How many points you have included here? A lot, a lot. Infinite, seemingly, yeah. Why? Because we are going from minus infinity to plus infinity. Seemingly, we are skipping a lot, yeah. Now, you have to write it down in a more general way, so that in a more mathematical way, we say. So we have to find a notation or invention to write it more in a more compact way. Now, if you construct this in this way, you can see if you put this n is an integer, right? Integer means minus 10, minus 9, whatever from infinity to 0, 1, 2, 3, 4, like that, right? If you put 0 here, you get half pi, right? Half pi means you are recovering this, see? Then you are going to put 1 here, then it's going to be 3 pi divided by 2, you are going to recover this. If you put 2 here, then you are going to recover the next one. If you are going to put 3 here, then you are going to recover next one. So likewise, if you put 1, 2, 3, 4, 5, 6, 7, 8 like that to this n, you are recovering everything beyond that point. Right? And if you put n minus 1, then you are going to recover this. Right? If you put n minus 1, you are going to recover this. This is when n minus 1. When you put n minus 2, you are going to recover this. Right? Minus 3, this. Minus 4, that. Likewise, you are going to recover the whole spectrum. Okay? So, this is the compact way of writing this guy. Okay, David. Chalo bhi deep.
They could go to court. You made this person. We don't need lawyers, we just say marks.
So I hope so far so good. Now, I think you have sine, cosine graphs and domains and the range in your mind. Retrieve it. For sine, what would be your x? What would be your this? This would be this. This is minus 1 to 1. Very good. Now visualize how the sine graph looks like. Restricted top by 1, restricted bottom by minus 1. Visualize. Then x goes to minus infinity like a wave. Right side goes to plus infinity like a wave. Then cos x. Cos x, again x is r, y is again minus 1 to 1. Now again, x, same thing, right? Same thing. Tan x, how tan x looks like?
Shit.
It does now.
Yeah, it does. It does.
So x would be r, all real numbers, but you have to understand because of the asymptotes, there are discontinuities. At what point? Pi divided by 2, 3 pi divided by 2. So you have to remember it, right? That's your knowledge, right? And then minus pi divided by 2. So how do you sort of write that in a compact way? Is n plus half pi. Yeah. Then y would be half. Let's talk about next. So this is what we learned. Just these two things. In summary, it's just very easy thing. Just 3 things. Next one. What's the question? Next one. Period of a circular function.
Notes taken. Where'd he go?
Timmy's like,
I'm gonna die today.
yeah.
Everyone.
So period of the circular function, right? Now, what is a period? From the word period, what a period is a length property, or period is a time property, or what?
It's kind of like a time property where it's where when you hit a certain point, it repeats again and again and again. I think. Oh, it could be. I don't know.
When it like starts
It's the
repeating.
length of a time.
Timmy, it's when it starts repeating.
Yeah, that's what I just said.
But like, time is
Hmm?
it's like when it starts repeating.
Like the point it starts with, yeah. That this oh it is a distance.
Sine.
Yeah.
Tim.
So this yeah. Yeah.
That's one period. And it just continues.
Yeah, yeah. So sine is 2 pi. Is it 2 pi for cos 2?
Yeah.
Is it 2 pi for cos 2? Is it 2 pi for cos?
And the rain. Some.
So
It's called something else in the top. Top.
Oh, that's
Like
like
the distance
isn't
between the
that
two
the
dots.
amplitude or something?
Those are the period.
Now look at this.
Yeah.
Uh,
Yeah, amplitude, yeah, yeah.
Okay, look at this. Period means period means period means period means the distance between the period repeated block. Repeated block, repeated block. That means, can you see this red one? Can you see this red one is repeated everywhere?
Yeah.
If you copy this, paste, copy this, paste, copy this, paste. Repeated block. What is the angle here? 0. What is the angle here? 2 pi. So the length of a period block, the length of a repeated block, right? So what is this length then?
2 pi.
It's actually 2 pi minus 0, right?
Okay.
2 pi. Right? So we say the period of sine curve is 2 pi. Period of sine is 2 pi. So if someone asks what is the period? The length of the repeated block. Now when it goes to cosine, again you can see if you copy paste, that's a period. So now here it's 0 again, 2 pi again here. So the period is given by t, okay, capital T. So capital T is equal to again 2 pi minus 0. It's again 2 pi. Okay. 2 pi minus 0 and it's again 2 pi. All good? Now go to tan. In tan, this is minus pi divided by 2 here. This is pi divided by 2 here. 0 here. So what is the period here? Period means the distance between distance of the repeated block. So that would be, t would be pi divided by 2 minus pi divided by 2. That's going to be pi. Okay. So the period of tan would be pi. Okay. So this is a point that we have to know because all the questions are coming under this period concept. So I'm dragging you to that one little by little. So we see.
So what would you use like a period? Like if a question like this came up on a test, like how would they ask something like that for a period?
So still do. So you need more knowledge
Okay.
to tackle exam kind of a question.
Scary.
What?
Scary.
It's not like I'm making it scary, right?
It's just a test. It's scary.
It's just a test. That's what I'm showing all my students like at the beginning. You know, in VCE, like, how old are you? 16, 17?
I'm still 15.
But when you are doing VCE, you are 16, 17, right?
Yes.
17 maybe. So all these kids are 17. We can't say kid because when I was 18, I had a girlfriend too. I'm telling you the truth.
Didn't you have like 10?
And
Is that what you said? You had like a lot of girlfriend?
when I was in 10,
When I was 10.
No. You said that you had a lot of girlfriends. Like more than one.
yeah, actually I told them my girlfriends. That's a different story. Because when you go to university, guys will be guys, girls will be girls, right? It's a different story. So everyone's life will have that that thing.
She got started.
So most important life in the life is the university life. University life means not the master's level or PhD level. That's very boring. The best life is university, undergraduate life. VC life, even myself, I was struggling. Do you think like I learned this like this? No, I worked so really hard to keep this like as it is. Now still I am throwing what I have learned. Otherwise, like nowadays, do you think like even I don't have any book or anything, right? I'm just referring if something is needed, a question or something. So it's what I have learned. But actually, if you think about this BCE thing in general, you guys are struggling with 6 subjects. Doesn't matter what 6 subjects, right? Don't think this subject is easy, this subject is hard, so I need to go for this. You are getting that decision blindly. Why? Do you think, honestly I'm asking, do you think these VC people are crazy? They will make an easy subject list, hard subject list, and then they give it to you, and then you will choose easy questions from subjects from easy subject list and you pass it? No. They are not stupid like that. We think these questions are easy, these subjects are easy, these subjects are hard. All are equally hard, guys. Right? But it is true that everybody can't do specialist math. Everybody can't do French. Why? I can't do French. I can't do biology. Why? Because my nature is not French. I am not a language person. Right? But I did chemistry. I'm not a chemistry guy too. Right? I'm a very mathematical. Even I have a master's degree in chemistry. And even in physics. I have 3 masters and 1 PhD. But I'm not a chemistry guy. But in the life, there are things that we have to do. Doesn't matter we like or not. Right? So if you go to these papers, you will see like equally you have to work for those things, right? Even English is a compulsory subject, right? Do you think English is easy? Hell no. See, English is not easy, hell no. When I talk to some people, they say, oh, English or nothing. My English is good. Yeah, I know. Like I have like very weird type of because I was born in there. Even like until I go to university in my country, I learned everything in my language. I can't speak one single word in English. Until I go to university. When I go to university, you know the funny thing. I was in the physics class, okay, in the university, because many subjects are compulsory. Now the lecturer came and I can remember, he was explaining the rotational motion of a ball. Right? Rotational motion like a ball, rotating, right? Rotational motion equation is this. He's saying, okay, write down the thing, guys, rotational motion, right? No one in the classroom knew what is rotational motion is. Even we couldn't understand what is rotation. Forget about the content. At least when I put rotational motion, you understand what is motion, what is rotation, right? The math is coming after, right? We didn't know what is rotational motion. But, yeah. So that's how the life is. But anyhow, coming back to the point, this is sine cos tan. Look at this now. Look at this. Little by little, I am training you for these kind of questions, right? And how they are going to ask these questions. Look, example. Plot fx is equal to sine x, where x is from 0 to 2 pi. They will give you the domain now. Specify the domain. When they specify the domain, yes, we are in our comfortable zone. Boom. 0 to 2 pi. Just that. Why? Am I going to draw all of this? I don't need to. I don't need to. So that means since these functions are infinitely extended, these functions are infinitely extended, right? This thing, right? All the exam questions are going to give you in this form by restricting the domain. Then you can focus on a certain part of the function. Make sense? And if I give you plot fx is equal to tan x, where x is from 0 to pi, how do you draw that? So 0 to pi, so I will take it from here. 0 to pi, you can see 0 here, pi here, right? I am restricting that. So it should be 0 here, pi divided by 2 here, pi here. Okay. So it would be 0 to pi, right? Okay, 0 to pi marked, and it will be like this. That's the function.